Integrated Problems number 2 for the General Chemistry 111. So today we're going to look at this integrated problem, all dealing with chlorine and swimming pools. All right, so we have 10 questions. It's very similar to the last one. First one we'll look at is chlorine has two naturally occurring isotopes, chlorine 35 and chlorine 37. What is the difference between these two isotopes? So if we look, we have chlorine 35, which we can abbreviate with the 35 up here, versus chlorine 37. Right? Remember that this number is the mass number, where A, the mass number, is equal to the number of protons plus the number of neutrons. And remember from our periodic table, the element symbol tells us the number of protons. So if we look here for chlorine, it has an atomic number of 17. Right? So it has 17 protons regardless of whatever its mass number is. Because it's chlorine, it has 17 protons. The number of neutrons we can determine from taking the mass number minus the number of protons. So the number of neutrons is going to equal to 35 minus 17, or 37 minus 17. So in chlorine 35, we have a total of 18 neutrons. And here we have 20 neutrons. Right? The question asking, remember, is the number of protons. What's the difference? Well, the difference between these two is the number of neutrons. So they have a different number of neutrons. The next one is how many protons or electrons are present in these two. Right? Again, we have chlorine 35 and chlorine 37. We saw from before that both of these had 17 protons, right, from its elemental symbol. The number of electrons, if these are neutral atoms, which they are, there's no charge here, the number of protons has to equal the number of electrons. So in both cases, these isotopes have 17 protons and 17 electrons. The next question, is chlorine a metal or a nonmetal? So we have to look back at the periodic table. Remember, things that are on this side of the periodic table are nonmetals. Things that are on this side are metals. So chlorine right here means that it is a nonmetal. So chlorine is a nonmetal. Because of its placement on the periodic table. Next question. Is chlorine is classified in which group on the periodic table? Again, we go back to where it is on the periodic table. It's in this group 7A or group 17. Remember, this group 8A or 18 is the noble gases, the one right next to it, including chlorine. These are the halogens. So chlorine is a halogen. So now let's get into some more complicated calculations. So its recommended concentration for the disinfection of a swimming pool is 1 part per million chlorine, or 1 gram of chlorine per 1 million grams of water. Calculate the volume of a chlorine solution in milliliters a homeowner should add to her swimming pool if the solution contains 6% chlorine by mass, and there are 2.0 times 10 to the 4th gallons of water in the pool. A couple of other things we have is that the 1 gallon is 7.39 liters, and assume the density for both the water, the pool water, and the chlorine solution is 1 gram per milliliter. So in this case, we have to take the volume of water in our swimming pool and convert that to the milliliters of this chlorine solution we need to add. So because this is the information we know about the pool, we know its volume, we have to figure out what volume of this solution in milliliters we have to add. So we're going to start there with this volume of water, this 2.0 times 10 to the 4th gallons of water. So we have to go from gallons of water to chlorine. And we know that the relationship between chlorine and water comes from this 1 ppm. We need to have enough chlorine so that we have 1 gram of chlorine for every million grams of water. So that means we have to convert from a volume of water into a mass of water. And we're going to do that by using the density. So we have to get this gallons of water into milliliters of water. So the first one we're going to do is convert to from gallons to liters. So we have 3.79 liters is for every 1 gallon of water. So our gallons cancel out. Now we have liters of water. The density is in milliliters, so we have to convert from liters to milliliters. We put 1 with the prefix, and then the prefix itself is for milliliters is 1 times 10 to the minus 3. And then now we have milliliters of water. We want to go to grams, so for every 1 milliliter, or 1.0 milliliters of water, we're going to get 1.0 grams of water. So now we've converted to the amount. If we stopped our calculation here, this would be a mass in grams of water. But we want this amount of solution. So then we have to convert then to using this amount here. For every 1 million grams of water, we need 1 gram of chlorine. So now we know how much chlorine we need to add. We then, our solution itself is 6%, or we get 6 grams of chlorine for every 100 grams of this chlorine solution. And then to get the volume, we're going to go through this density again. Remember that the density we assumed for this chlorine solution is 1 gram. So for every 1 gram of the chlorine solution, we get 1 milliliter of that chlorine solution. So again, we multiply everything on the top, divide everything on the bottom. When we do that, we end up with 1263.3 milliliters of this solution we have to add. Right, the last thing, as always, we need to worry about is the number of significant figures. We have 2 here in our volume. We have 1 in this concentration and 2 here. So we're going to end up with having a single significant figure. So this rounds to approximately 1,000 milliliters of that chlorine solution is needed to take our 2.0 times 10 to the fourth gallons of pool water and raise it to a concentration of 1 ppm. Okay. Let's continue. So if the swimming pool has the dimensions of 16 feet by 25 feet, what is the depth of this swimming pool? All right, so let's start by looking at a sort of a rough sketch of this swimming pool. All right, if we treat it as this cube, or not, I guess it's not a cube, it's going to be more of a box, then this is going to be 25 feet in length and 16 feet in width. What we're trying to calculate is this depth D. Right? Remember that the volume of this box is equal to the length times the width times the height. Right? Or 25 feet by 16 feet by this depth D. Remember also from our previous example, or previous problem, that the volume of this pool contained 2.0 times 10 to the fourth gallons. So if we assume that that's going to be all the way to the top of our swimming pool, then this volume has to be equal to 2.0 times 10 to the fourth gallons. So we have to convert then this volume in gallons to this volume in cubic measurements. So we either have to convert gallons to cubic feet or this feet into gallons. I think it's easier to, again, start with this value and calculate this in cubic feet. So we're going to start with this 2.0 times 10 to the fourth gallons of water. And just like before, 1 gallon is 3.79 liters. Right? So now we go from the English unit to the metric unit, because we can convert between metric units fairly simply, so we're going to go there. Right? How we go from this measurement depends on what we have. Right? Looking at our excuse me, periodic table that we have everything on, we see that we have a variety of different options to convert volume between this metric unit and this cubic feet. So we want to see here that there's 1 cubic meter is 35.3 cubic feet. Right? And 1 liter, and if you get to cubic meters, there's 1 decimeter cubed is 10 to the negative 3 meters cubed, and 1 decimeter cubed is 1 liter. So we're going to use those conversions to help us out here. From that, we saw that 1 liter is 1 decimeter cubed, and 1 decimeter cubed is 1 times 10 to the negative 3 meters cubed. And the final one was for every 1 meter cubed, we get 35.3 cubic feet. Right? So again, these conversions came directly off of our periodic table and helpful conversions list. Right? We don't have to have necessarily all of those memorized. So now we've doing the math, the top multiplied, the bottom divided, we find that we get 2675.74 cubic feet is equal to 2.0 times 10 to the fourth gallons. Right? So this is our volume here in cubic feet. So this 2675.74 cubic feet has to be equal to the 25 feet times the 16 feet times our depth in feet. So again, divide this number by both of those, and we end up getting our depth being 6.689 feet. Again, if we account for significant figures, these both have 2. This one has 2, so our final answer should have 2 significant figures. So we're going to convert this to 6.7 feet in depth. So again, dimensional analysis, where we're working with our units plus the definition of a volume, makes this problem fairly straightforward. So the next question is, what is the mass of this pool water? So we remember from before, from the original problem, or a couple problems back, we said we had a volume of 2.0 times 10 to the 4th gallons. Right? And remember that the density of this water is 1.0 grams per milliliter. Right? So if we have a volume and a density, we can calculate a mass. So we're going to do something very similar as we've done several times already. We're going to take the 2.0 times 10 to the 4th gallons, convert from the English to the metric. 1 gallon is 3.79 liters. We want to get to milliliters so that we can use this density. So 1 times 10 to the negative 3 liters is equal to 1 milliliter. And we get 1.0 grams of water for every 1 milliliter of water. So when we do that, multiply on top, divide on the bottom, we get 7.58 times 10 to the 7th grams. Again, looking at our significant figures, we should have 2, so our answer then, because we have 2 here and we had 2 here, so this should be 7.6 times 10 to the 7th grams of H2O. Technically, because we don't specify a unit, we could use any unit of mass. We could use pounds, but since we have the first unit of mass we get to is this grams, I'm going to stop there. So you can stop at whatever unit of mass you want, unless it's specified in the question. This one, it wasn't. Continuing on, if the swimming pool water was run through a filter at a rate of 4.85 liters per minute, how long would it take in hours for all the water to run through the filter? So we have to run all of the water through that filter, and it's going at 4.85 liters per minute. Well, we know the amount of water we had was the 2.0 times 10 to the 4th gallons. Right? And we know that every 1 gallon is 3.79 liters. So now we have the volume. I guess we've been using this enough. We probably could have stopped and actually calculated the volume of this pool in liters and used that number continuously. But this calculation is fairly straightforward, so we can just continue to use it. And from our problem here, we say that we run through 4.85 liters of water in 1 minute. Right? So this is going to allow us to convert from liters of water into minutes. And we want our time in hours, so we know that there is 60 minutes in 1 hour. Again, as always, multiply across the top, divide across the bottom, and we get 2.6 times 10 to the 2nd hours. Right. Looking at significant figures, this number has 2, that number has 3, so we're going to stick with this number as being 2, so we see that we get the same. We don't have to round any on this problem. The next problem. If the homeowner were 175 centimeters tall, would they be able to touch the bottom of the pool without completely being submerged? Remember from previously that we said that the depth of the pool we calculated as being 6.7 feet. So our depth is 6.7 feet. If they are 125 or 175 centimeters tall, excuse me, we have to compare those two units directly. So we can either convert this 6.7 feet to centimeters or the 175 centimeters to feet. I think I'm going to convert this one, and then we're going to compare it to that depth. So we have 175 centimeters tall. Again, we have a variety of different conversions we can choose from. The one I have memorized and I typically use is this inches to centimeters, and then I know how many inches are in a foot, so that we can use that. So 1 inch is 2.54 centimeters. So now we're going to get the height in inches, but we don't want to compare inches, we want to compare feet. So there's 12 inches in 1 foot. So 175 divided by 2.54 divided by 12 gives us 5.7 feet tall. And so we can do the comparison. 5.7 feet is our person. That is going to be less than the 6.7 feet deep. So this person is not going to be able to touch. So they would not be able to touch. All right, last question. If the homeowner used a pool to swim laps, how many lengths of the pool would the homeowner have to swim if we wanted to do 1.00 times 10 to the 4th meter workout? Right. So we can look, if we go back to the picture of our pool, right, look at the top view, then this length was 25 feet. This was 16. I would assume that the homeowner is going to want to swim the longest stretch, so we're going to use this 25 feet. Right? So if we can convert this distance to meters, then we can figure out how many of those segments we have to swim in order to get to this 1.0 times 10 to the 4th meters. So we're going to take this 25 feet and convert it to meters. So this is 25 feet per 1 length, I'm going to call it. And we know that there's 12 inches in every 1 foot. And there's 1 inch is 2.54 centimeters. Again, same conversion we had before. And for every 1 centimeter, we have 1 times 10 to the negative 2 meters. So then doing this, we can calculate how many meters we have per length. So let's take a second and do that. 25 times 12 times 2.54 times 1 to the 2 minus divided by the 1s gives us 7.62 meters per length. If we want to do a workout that's 1.00 times 10 to the 4th meters, then we can divide this by the 7.62 meters per 1 length and calculate how many lengths we need to swim. Right? Do that, we see that we get 1312 lengths. So if they want to do this workout, we're going to assume they're going to want to swim a specific number of lengths, so then the significant figures aren't really, we're going to use those by counting, so we would actually want to carry all of those digits out. So they're going to have to swim 1,312 lengths of the pool to do a 1.0 times 10 to the 4th meter workout. Again, so most of these problems were, besides looking at the information about chlorine from the periodic table, the rest of this is all dimensional analysis, fairly straightforward. Set it up with our ratios, everything on the top we multiply, everything by on the bottom we divide, and if we can get our units to work out to the answer we want, 99% of the time our math is going to be correct.